And now that we've explained procedures, let's look again at data types. So far, we've seen integers, floating point numbers, and lists. So far, lists are the only compound data type we've seen. In fact, the OS kernel language has a much more general form of compound type than a list called a record. And a list is just a special form of record. So a record groups together a set of values into a single compound value, and each value is indexed by an integer or a symbol called an atom. So we have the notion of record, and we have also the notion of an atom that we introduce together with a record. So an atom is a sequence of characters that you type that starts with a lowercase character. An atom is a symbolic constant, and it's very useful in symbolic calculations. So all symbolic languages, they support atoms. So let me give some examples here. Let me start by using a list with atoms in it. So L is the list with 4 elements: John, Paul, George, and Ringo. So these are 4 atoms. Okay, and we can display this. Okay, the list with 4 atoms here. Okay, and now we can do calculations with this. We can do, for example, as before, L.2.2.1, which returns what? Which atom is it returning? George. Okay, fine. Now let's declare a record. And you'll see the difference. So a record, let's call it a rectangle with 4 fields. A field called bottom, whose value is 10. A field called left, whose value is 20. A field called top, value 100. And a field called right, whose value is 110. Okay, so this is a record grouping 4 integers together. Browse R. I see the record. So the atom rectangle is called the label of the record, and it in some sense indicates the type of the record. And then there are 4 atoms that are called the field names, or sometimes also called the features. So we have bottom, left, top, and right. And each of the field names has a field 10, 20, 100, and 110. And in order to access the different fields, we can use the dot operation. Now we can do something like browse r dot bottom. This will return 10. Or we can do browse r dot right minus r dot left. Okay, and this returns 90. So the dot operation is in fact very similar to the dot operation for lists. Remember the dot operation for lists? Here is an example. Well, it shows that actually lists are records with fields 1 and 2. So lists are records. So for example, I can say L1 is A bar nil, browse L1. So this is what we saw before. It's the bar notation for lists. But in fact, lists are a special case of record. So I can say L2 is equal to, the label is a vertical bar. I have to introduce it between quotes. Otherwise, the parser gets confused because it thinks the bar has to be in the middle. If I want to use it by itself, here in the front, I put it in quotes, and the number 1 field is A, and the number 2 field is nil. So if I browse L2 here, then I get the same list as before. In fact, I can compare L1 and L2, and they are exactly the same. So what this means is that the bar notation is in fact already a syntactic sugar. The real primitive notation, the one that's in the kernel language, is this one, is the record notation. Okay? Our original definition of lists was already a form of syntactic sugar. Okay? So records are the only compound data type in the kernel language. So they are a very general data type, and we will define many other data types in terms of records. So we've already used them to define lists, and later on we'll use them to define trees. For example, in the next lesson, we can do calculations with records. Let me show you some of the many operations that are available. So, for example, we have the record R. Remember that we created here, the rectangle. We have several ways to calculate this. We have an operation called width of R. This gives you the number of fields in the record. And of course, you will understand what is the width of L. Remember the list L we defined here with 4 elements? What is the width of L? If you said 2, you're right, because the list is, of course, a recursive data structure, and if a list has 4 elements, the top level is still a record with 1 and 2 fields, so the 2 field would be the list of the remaining elements. So there's another operation called arity. This is a more sophisticated operation than width. It returns a list of all the field names. So arity of R here returns a list of 4 atoms, bottom, left, right, top. And if I do arity of L, what does it return? What is the top level of a list? What are the names of the fields? Well, it's 1 and 2. Okay, so returns the lists 1 and 2. And a final operation that I want to show is a simple one. It's called label, which returns simply the label of the record. So label of R returns rectangle. And label of L, what does it return? Well, it returns a vertical bar.